Great. Hi, I'm Dr. Meg Schwam. I'm a senior lecturer here at Queen's University Belfast, and I'm here with Dr. Matthew Dobson to talk about his upcoming exciting paper talking about Centaur Chiron and some weird stuff that's been going on with it. So, Matthew, do you want to start by telling us a little bit about yourself and, why were you studying Chiron and what is Chiron? Tell us a little bit more.
Sure. Hi, folks. I am Matthew Dobson. I'm a PhD student at the Astrophysics Research Centre at Queen's University Belfast. I study the small objects of the solar system. These are essentially the remnants from planetary formation 4.5 billion years ago that act as time capsules because they've changed very little over the course of the solar system's history. So therefore, by studying them, it's like a sort of interplanetary archaeology. We can gaze into the solar system's past. And one of these small solar system objects is Chiron. Now, Chiron is an especially interesting and weird planetesimal object. It's one of the largest of what we call the centaurs of the solar system. These are small icy planetesimals orbiting between the giant planets. And Chiron is, like other members of the population, known to behave similar to a comet, where it emits an atmosphere of icy gas and dust. And in addition to being
Do,
one of the largest
hey,
of the centaurs,
do all
oh,
do all centaurs do this? Are they all active?
um, not all of them. Some of them are. Now, as for how many are or aren't, that's currently a matter of debate because these objects are very, very distant, which means they could be active, but we're just not seeing it because they could be too far away for us to
So,
see the telltale coma.
so centaurs are maybe sometimes comets. Are where do they come from? So where do these objects originate from?
They came from the Kuiper Belt, which is a sea of primordial planetesimals orbiting just beyond Neptune. Now, some of these can be scattered by Neptune's gravity into the giant planet region. And because they're amid these very massive giant planets, their orbits are very unstable. It's sort of like a game of pinball where they're scattered across the giant planet region until eventually they can be perturbed by Jupiter to have their orbital dynamics dominated entirely by Jupiter's gravity, where they would become Jupiter family comets. So they're
So you've
essentially
got
an evolutionary midpoint between the primordial Kuiper belt and the more evolved short period comets.
so it's not a centaur, or rather, a centaur's not quite a comet, not quite a Kuiper Belt object.
It's essentially half and half. It's a half Kuiper belt object, half comet. It's sort of transitioning from one to the other.
So is that why against the name of centaurs half human, half horse? So maybe that fits quite well.
Absolutely, yes. And to add to that, because the mythological centaurs were sort of wild and untamable, likewise, these centaurs are orbiting on these wild, chaotic orbits.
Okay. So Chiron's special, you said, because it's sometime active and it's large. So
Yes.
Chiron's is sort of the, you know, big fish in a small pond, maybe? Is that one
Yes.
way to think about it?
Yes. It's very large for a centaur, one of the largest. To put it into context, most centaurs would be less than 100 kilometers in diameter. This thing is closer to 200. So not only is it very large, it also has a system of icy debris rings, sort of like Saturn's rings, but much smaller. And we've only and this seems to be actually unusually more common than we would think, not just in centaurs, but also in terms of planetesimals. So how these rings formed, that's currently a very interesting question that researchers are trying to figure out. So it's a very strange object. It's got Saturn-like rings and is also a comet and is also quite large. And it's currently transitioning from being this primordial Kuiper object to a comet. So
So
it's certainly an interesting object.
yeah, that sounds pretty exciting. I know all about your research, so I know it's super exciting. So Chiron has been weird, and it sounds like it got weirder. So do you want to talk about how did you figure out it was weird? What happened? So
Ah,
can you tell us
yes.
a bit about that
Yes.
story of how did you what happened? What made you decide to really go deep dive into studying Chiron for the past few years?
Well, my research uses data, mainly uses data from what's we call the Asteroid Terrestrial Impact Last Alert System, or ATLAS survey. And this consists of 4 telescopes in Hawaii, South Africa, and Chile that are daily observing the entire night sky. So as a result, we're getting daily observations of loads and loads of objects. The main mission of ATLAS is to detect and characterize and give fair warning for any asteroids that could pose a potential impact hazard to Earth. But it also serendipitously observes many, many solar system objects purely just because they happen to be in the frame of the observation. So as a result, Atlas had gathered years and years of data on Chiron, and we were able to plot its brightness across time. And we noticed that in 2021, when it had come back from behind the sun, it had suddenly shot up in brightness, suddenly and completely unexpectedly. And we weren't quite sure as to why. Could this have
So,
been uh,
so, so,
uh,
so you're saying is that like it was behind the sun, so you
mhm,
couldn't observe it, and then
yes.
when it came back around, it was different.
Indeed, because before it became behind the sun, it was consistent with what we'd seen for the previous years, and yet something happened during that time that we couldn't observe it, and it suddenly shot up in brightness.
So that's a pretty fun cosmic mystery of literally that if it had been at any other time, you might have added more about what exactly happened. But so you're playing catch up in some sense of like the fact of you didn't actually see what happened, or you're, I guess, a couple months later, you're seeing it again to then look at it. So
Yeah,
what did you
there's a
have to
sort.
do to try to figure out what was going on?
Well, as you say, it was a sort of a game of catch up. There was a sort of delay between whatever happened and what we're now seeing. So, in terms of what we did, what it was kind of like when a detective tried to solve a mystery, they would gather as much evidence from as many sources and about alibis as possible. And I did a similar thing because there are several ongoing wide field surveys as well as Atlas. So what I did was I collated as many of these observations and brightness measurements across time I could from not just Atlas but also like sort of the Zwicky Transient Facility and the Las Cumbres Observatory. And also we programmed observations with the Gemini telescope, which is one of the largest telescopes in the world. And the great thing about Gemini is that because it's so large, it can capture more light and thus allow us to see fainter phenomena than most telescopes.
So
So
if you're seeing fainter phenomena, why would you want to go deeper if you could already see it in other smaller telescopes? You talked about alibis. Who were you trying to what kind of suspects were you trying to rule out?
well, we'd already ruled out it could be that it being due to its rotation because the brightness increase was far greater than anything that the object spinning on its axis could cause. We also ruled out its what we call the phase effects, which is, I guess, in short, it's lunar phases where we see different fractions of its surface illuminated at different angles. The brightness variation in that was much smaller than what we actually saw when it shot up. We'd also ruled out a new surface feature coming into view as it progressed along its orbit because this brightness increase was so quick. It was implausible to have happened. It would have been implausible that a very bright surface feature could have suddenly come into view in such a short length of time, which meant that there were two main suspects. Either it could be cometary activity, or it could be due to Chiron's ring system reflecting
So
astrolight.
so how could it be possibly the rings? Like they're there, but like, how is like we get light reflecting back from Chiron, okay? But
Uh-huh.
you have these rings. How is the rings were that have been there, right? So how could something have changed in that like moment, that those months in 2021, that would make the rings do that?
Well, that's due to that's a very good question, and the answer is due to Chiron's axial tilt because it's tilted with respect to our perspective on Earth, and as a result, the ring system is tilted. Now, so at some point of its orbit, we can see the rings sort of edge on like this, but other parts of its orbit we see it's roughly face on or closer to being face on, and when it's at this stage, it's got a greater visible surface area and is therefore reflecting more light. And we see this, we can see this in the light curve across time, where we see these very large variations in brightness that are at least partly caused by this ring system. So much in a similar way that Saturn is sort of is tilted on its axis, and we would see different fractions of the ring system illuminated across its orbit. This is a very similar thing happening with Chiron.
So you're saying is that we just could have entered a different viewpoint of the rings, or is there anything else that could have happened in the rings that might cause change in how much light is being reflected off from the ice particles or dust particles within the rings?
It could very well be the changing viewing angle. It might also be that within the rings there could be as yet undiscovered shepherd moons that are confining the ring material to the ring shapes. Now these may collide, and in doing so cause the brightness increase that we may have seen, and would
So
also
you're
in doing so augment the rings.
so you're saying is that okay? So it could be something event happened in the rings, and so they're different now
Mhm.
over that period of time, or they've come into view, right? That's more that we could see, or again, it's that orientation possibly causing more, right? That it hit a point in its orbit, just happened to be behind the sun. Um, very lucky, more fortuitous. That would then cause that change. You said the rings were one option.
Mhm.
Is there another culprit then that could be not the rings itself?
It could be, yes. See, Chiron has known to exhibit cometary activity in the past, whereby it emits a large and extended atmosphere of icy gas and dust. And historically, such a coma has been visible in the images because because Chiron looks very fuzzy. It looks like it has a very fuzzy cloud around it. So that was our first port of call to actually check the Atlas observations. But it turns out that we couldn't see any coma. It looked as though nothing was there. So it could
So
be that maybe the coma was fainter than we could see. It was actually there, but we just couldn't see it.
So you mentioned that you looked in Atlas to see if there was a coma, but you
Mhm.
also talked about the Gemini Observatory and being a big light bucket. So what did the big light bucket see? Because I'm assuming you brought out the big guns when the small telescopes didn't see it to go try to find stuff. So what did the big collecting area to images tell you?
That was exactly our logic behind it. Basically, increase the size of the light bucket, see what we can get. Um, Rather surprisingly, we didn't actually see any coma in the Gemini observations either. They showed that similar to likes of Atlas and ZT and the other Atlas and the other smaller telescopes, we couldn't actually see any coma. It was consistent with the background. It looks pretty much like a background star.
So
But
wait. There's no, so you didn't see the telltale sign of a coma. So isn't that, the tail, the coma is, the fuzziness is what defines a comet. So does that mean that it totally ruled out cometary activity?
no, not at all. Just because we couldn't see a coma there doesn't mean it isn't there. It could be that, you see, one very interesting thing about when Chiron shot up in brightness is that it was at its furthest point from the sun. It's aphelion, and at this distance, it was so far that estimates for how bright the coma would be meant that we may not have been able to even see it in Gemini. It was just so far away that it would be too dim to see. Alternatively, and this ties back to Chiron being rather unusual for a centaur, because it's so big, it has a much larger gravity than your average comet, which is the gravity of which is essentially negligible. But it meant that Chiron's mass could constrain any coma material to its immediate vicinity of its surface, meaning that it wouldn't actually be able to extend out into space. And because this object is so distant, we wouldn't actually be able to resolve it to to a good enough resolution for us to be able to discern the object from the coma itself. They would just be blurred into one signal.
So does that mean like the coma then is right with Chiron, right? They look the same. It's like one source on your image, like right. And so then you're getting more light, like because a coma is adding more dust around the object. Does that mean
Mm.
that you would be getting more light reflecting back, and that's what's causing the change.
Exactly, exactly. The presence of a coma increases the overall surface area of that light can be reflected back from, and thus when this increases, the light reflected back increases. So this is what will cause the change, and also because coma material tends to be quite icy, and these tend to be quite these may be quite high albedo, and thus maybe more reflective than the surface as a whole. So it would also act to increase the reflectance as well, not just the surface area, but also what's all the type of material that's being used to augment the surface area.
So it could just be that you're unlucky in the
Yeah,
sense of it's too faint to see. And that, right, it's or right, like you can't, it's too faint to see, or it's, just bound. So between the two hypotheses you have, it sounds like you were doing some more digging between the rings and cometary activity. Who's your main suspect?
well, for us, the main suspect is cometary activity. Simply because the evolution in Chiron's brightness since it shot up is very akin to what we call the cometary outburst, which is a sudden but brief period of cometary activity, whereby the comet shoots up in brightness, the cometary activity ceases, and then the coma dissipates, and that causes in a light with the light curve a sudden increase in brightness, and then a very slow exponential decay. And we've seen that over the subsequent years to roughly the present day, Chiron has remained brighter than it was before this event. So something's still happening, as it were. It could be that coma is still there and still dissipating. And for us that was the thing that really made us think this is our prime suspect, because current models of Chiron's ring system have failed to replicate the brightness evolution that we've seen in the recent couple of years. It just can't explain it, at least in terms of our current understanding. Now, we can't rule out the rings entirely. It could be that the present understanding of Chiron's ring system does not accurately describe what the ring system is actually like. So in which case, better models would be needed to compute how this rings would affect Chiron's brightness.
So you talked about that in terms of thinking about, like you said, as if there was a moon collision, that's not going to be in this model that has come up like from past occultation surveys that modeled the rings years ago.
Mhm.
So you're saying is like that scenario, right? You don't have a model for because, well, someone has to go think about how when you take two moonlets and smack them into each other, how that might distribute around in a ring.
Exactly. It could even create more rings, in which case you would need to account for a ring model having different numbers of rings across time. Um, so it meant that while we couldn't rule it out, we still thought that the brightness behavior that Chiron has shown was much more indicative of an outburst of cometary activity than the rings.
So it sort of sounds like a duck, walks like a duck, is a duck in some sense, right? Or maybe you can't see the duck, so you hear the duck, you hear it splashing in the water, kind
Yes,
of.
that's a very good analogy.
Because I've heard, I mean, I know that Chiron's been active in the past and like, right. And so
Mm,
it's done periods of activity for months, right?
mm.
So most cometary activity is kind of quick, right? You talked about in terms of outbursts, they're pretty quick, right? They outburst, and comets get brighter, and they like sort of evolve back down in terms of their brightness. But Chiron's been weird before, right? And then it's done things does things its own way, right? In the sense of
Yeah,
it's been active for months, right? Is
indeed.
that right in terms of comparing what you think you're seeing to what Chiron has done in the past?
Indeed, months, possibly even years at a time. Because if this turns out to be a cometary outburst, and this is extended, the overall effect of this has extended for multiple years, which stands in contrast to other centaurs as well, because there are other centaurs like the one of the most active objects in the solar system is a centaur we call 29P Schwarzmann-Wachmann 1. It is outbursting all the time, or with outbursts lasting from sometimes minutes, sometimes days. It's just constantly doing stuff, but on really, really short, but really, really frequent timescales. In the middle of that, you have the likes of other centaurs like what's called Echeclus, which is sort of slightly smaller than Chiron, but has exhibited outbursts which last for months at a time. But Chiron is even longer. So even the cometary activity exhibited by Chiron is still unusually long compared to the rest of centaurs. Such an oddball object.
So, so it sounds like your thought is you can't totally rule out the rings, but your main suspect, the one that you want to interview, right? The one that you want to like, tail is, is cometary activity, that there's a new outburst or possibly this thing's been active for a while. And like it jumped into high gear, right? Something changed on the surface or exposed, and that you've got now a bigger outburst.
Indeed.
So you've gotten that, but it sounds like from your data, right, it's all imagery, photometry. So you don't have the smoking gun of a coma or a tail to tell you or showing signs of outgassing. So your paper is all about that. But there's some extra recent results that have been a preprint's been put online. So do you want to talk a little bit about that in terms of your context of your results?
Indeed, yes. This independent team have used the James Webb Space Telescope (JWST) to observe Chiron about a year or so ago, taking this one snapshot in time to analyze the centaur, and they've discovered that it is in fact exhibiting a coma. We just couldn't see it in our observations, but we're able to discern from, as I say, not the smoking gun, but from other slightly more oblique evidence that this was likely a coma. But basically, they
So
prove we're right.
So I guess the one way to think about it is like you've done all of this, you're investigating, a crime scene, right? And you figure out who it is, you arrest the person, right, the perpetrator, and then you find a key witness is like, yeah, I saw that person break into that house. And so the JWST results are kind of that witness of like, yep, I saw that because I was watching. So is that one way to think about it in terms of that JVST sort of puts your observations into context?
Indeed, yes, that's an excellent analogy, I must say. But yeah, essentially, it confirms this frightening event as cometary activity.
Very cool.
Indeed.
So why is this important? So, okay, Karen's active. It's a really fun like story of like if something changed, you've done all the investigation. Okay, so now we know it's cometary activity. Why is that important? Thinking about just Chiron itself, but also the centaurs.
Mhm. Well, in terms of Chiron itself, it's important because it's very unusual why Chiron would become active perhaps the furthest away from the sun it can be, as opposed to being close to the sun where it would get more solar radiation, more heat, and one would think that would cause more cometary activity. So in doing so, because of that, we were able to rule out certain mechanisms for what could be causing this activity. For example, Chiron is way, way too far out and too cold at the moment for it to be sunlight directly sublimating water ice on the surface. And it meant that possible candidates could be that there's actually water ice underneath the surface that is in a sort of irregular molecular formation, but due to heat can then become a more crystalline formation. And this is an exothermic reaction, which means it can heat up itself. Alternatively, it could be that there's either carbon monoxide or carbon dioxide volatile ices that there's a little patch on the surface that has just recently um, come into view of the sun, as it were. Solar radiation is heating up, and this has triggered a massive outburst.
So it just basically sublimates away and goes from ice to gas, and so it's lifting stuff off the surface and creating the dusty coma, or some putting up particles that are then reflecting more light back.
Indeed, indeed. And this is
So
and this I guess this would probably relate to the centaur population as a whole, because I've mentioned that centaurs can sometimes exhibit cometary activity. The exact mechanism as to what causes that activity, researchers are not entirely certain about. We have several ideas, as I mentioned, the amorphous crystalline water ice transition, or else maybe pockets of carbon monoxide or carbon dioxide gas. But these centaurs are so far away that we simply it's quite hard to observe them, especially in terms of comets or short period comets, which tend to be nearer. So as a result, we would need more data and more observations of more of more centaur outbursts to be able to figure out exactly what could be causing this. So essentially, every
if
time.
we think we think about the centaurs, right, it might be
Mhm,
a hodgepodge of these different mechanisms, right? Because they're so they were kind of diffusing in, right, pinballing like a big game of pinball, right,
mhm.
within the middle solar system. So it might be that there's all of these different mechanisms going on at different points and possible times within a centaur's lifetime, possibly.
It could be, yes. I mean, the centaurs that would be more pristine and sort of the ones that have been diffused from the Kuiper Belt most recently, they'll probably have more volatile ices in their overall composition. This might mean
Totally.
that we get more it's maybe more dominated by CO, carbon monoxide or carbon dioxide gas, whereas those that are say more evolved, maybe say due to maybe it's due to materials that's deeper within the surface because the upper levels of the surface have been more depleted. But yes, it's a
But we don't see all centaurs active, right? So this is sort of
no,
again one of the mysteries of not every centaur turns on, right?
no, no, indeed.
And so there's work or people are theorizing whether having certain, and I know there's been talk of jumps in orbits, right, that might cause the ability or cause a different environment, right, or thermal waves that might change your activity. So it sounds like this is something of right a lot of different factors that might be convolved together to create cometary activity on this population. Um, but how is that interesting? I guess if we think about it in terms of their, just in terms of studying them, it seems like it's useful because they're such a weird population. And again, understanding our active solar system seems important. But we think of that in terms of the Jupiter family comets, right? That like you talked about them being sort of that maybe it's the if we go back to analogies, it's the caterpillar in the cocoon. If you talk about the JFCs being the butterfly and the caterpillar being the Kuiper Belt objects, how does that cometary activity in terms of what's going on in that cocoon stage and the centaur stage matter when you think about the JFCs, the short period comets, things that people actually have occasionally maybe seen by eye, or maybe have delivered water to the Earth.
Indeed. Well, because centaurs are this evolutionary midpoint, they're sort of, they're half Kuiper Belt object, half Jupiter family comet, not quite one or the other, but on their way to become, on their way from one stage to the next stage. Figuring out how Kuiper Belt objects, which don't exhibit cometary activity, turn into comets, which do exhibit activity, working out how we progress from A to B, essentially, or I guess from A to B to C in the case, with the B stage being centaurs, is a key element in understanding the evolution of Jupiter family comets, and also working out whether the mechanism behind centaur activity is also similar to that for Jupiter family comets. Is it that something happens? Is it something happens that's at a certain distance that doesn't happen maybe close to the sun, or do other mechanisms take over the closer they get to the sun, or is it maybe due to say they eventually get depleted of one type of volatile and then move on to the next one? Working out how all that happens, how centaurs evolve, as they become less pristine and more evolved, how does it actually manifest? Does it surface change? Do they change color? Does it become less ragged and more smooth on its surface? Working out how one evolves to the other, that's the main thing, because in these time capsules essentially beyond Neptune, how they go from these primordial objects that have barely changed over 4.5 billion years, these beautiful comets we see in the night sky. That's a very big step in understanding how we get from one to the other.
But
Being
I
able
think
to
it
know what
also
central
is,
activity
but I also think it's
was what.
that it's to understand the Jupiter family comets, you got to understand how they started. Like, what is their
Yes,
input
yeah,
state? And so we studied Jupiter family comets as they are now, and we don't necessarily understand what they look like when they first become a Jupiter family comet. Now, that boundary seems to be fuzzy, and things seem to maybe move between the Centaurs and the JFCs back and forth a little bit, in terms of dynamics, in terms of scattering. So it may not be as pretty or as easy. It may be that, it may be that it, again, sort of you live a little bit as a JFC and you move back over, and that this is part of the, that might complicate things a bit. But it sounds like, it's really trying to understand, right? If we want to understand our Jupiter family comets, we have to understand where they came from and what their bulk of the starting point was, what they looked like. So it sounds like it's exciting in that sense too, of, as you said, all these different mechanisms. And understanding, right, what's going on there informs what we know about the Jupiter family comets, right? It's one
indeed,
of
because
our populations of short period comets.
indeed,
So
because centaurs are sort of comets waiting in the sorry, comets just waiting in the wing to sort of become comets. So working out that sort of the end stage of centaurs, which is the start stage of Jupiter family comets. Like how pristine could they be compared to the Kuiper belts? Yeah, no, that is an active period, an active area of study at the moment, and
well,
it's not entirely clear
yeah.
how
So it
sort of
seems like
how.
it's worth thinking about the fact that you said that, centaurs are comets waiting in the wings, but not all centaurs, right, are made equal, and not all centaurs will become Jupiter family comets. Is that right?
No, indeed, no, indeed. Some do become Jupiter family comets. Some, when they're perturbed by Jupiter, can be flung out of the solar system entirely.
Is it only
Others,
Jupiter,
well,
or are there other planets can kick them out?
I think Jupiter's probably the most likely to kick them out due to its overwhelmingly large mass. I think it's technically possible, but Jupiter tends to dominate in terms of the end state, in terms of how centaurs end up when it comes to planetary interactions. Another possibility is that they can actually impact another giant planet, and we've seen that with comet Shoemaker-Levy 9, whereby it was
Was
likely a centaur that became a comet but was then ripped apart. But this could, dynamical studies have shown that this could happen to centaurs.
Wow. I mean, so that I think the 30th anniversary of Comet Shoemaker-Levy 9 is about now, I believe.
I think so. Yeah, yeah. As
So, but Comet Shoemaker-Levy 9 is a comet, right? So it's not a centaur that hit Jupiter.
no, of
It
course,
is,
no.
right? It's that you're saying is that the possibility is that a centaur will transition to being a short period comet. It could be kicked out of the solar system in one way or another with interactions with planets, or possibly, right, in a rare instance, maybe will, impact a giant planet.
Indeed, yes, no, that is correct.
So, and the only sort of big celestial impact we've seen, that we've had astronomers looking, was Shoemaker-Levy 9. I remember seeing the HST observations, Hubble Space Telescope observations of the scars from the string of pearls because the comet nucleus broke up,
Mhm.
impacting Jupiter's atmosphere. So,
And that reveals so much about Jupiter's interior as well. Just another sort of oblique, like how one sort of can unlock another thing in planetary science is all interrelated.
sounds like the solar system is quite a active and interesting place. Sometimes we think of it all as being primordial or pristine, or the planets are changing, right? That Earth has lots of processes going on. Mars has processes, winds and dunes and things that are changing. Possibly water at some point has polar caps that change in their size and sublimate and have carbon dioxide snow. But that we sometimes forget that other things in our solar system are quite active. So it's kind of fun to think about, that Chiron kind of did a lot of interesting things in the past few years.
Oh, indeed.
So it's been really great to share this detective story, and congratulations on the paper as your thesis advisor. I get to say that too, as a co-author, because it's really been, I think, an exciting adventure that I've been really stoked about, to watch you sort of help coordinate this team and unravel this mystery, because it has been kind of exciting to be like, what happened to this thing? So it's really nice to finally be able to tell the story to people, after all these many years of working on this data set, to try to figure out what's going on with Chiron. So
Well,
thanks so
thank you
much.
very much, mate. No, thank you very much, mate. No, thank you very much. No, it was great to talk about it, certainly. Indeed, now for sure we know what this is.
Great.